Welcome to this course on Introduction to the Python Programming and its Application. In this lecture, we will going to tell you how to create a model and what are the different models available in the PyCaret library. Now, what are the different models available in this PyCaret? So we want to see that what are the different models are available. Okay, you can use any of the model, but you should be aware that okay, which models are available in this. So we can check out the number of models that are available. Again, what we are doing, we are using the classification task. So in a classification task, we have got a different models, and in a regression task, we have got a different model. Okay, some models can be common. Okay, but you have to call it from the particular task problem. So I'm going for the classification. So I'm writing from PyCaret got classification import models. Okay, and I want to display this model, so I will be calling these models, and you will going to see that all the models will going to be listed here. So we have got a ID. Again, these are the short name which you will be using. So we have got a LR. So LR means we are talking about the logistic regression. Okay. Then we have got a KNN, K neighbor classifier, NB neighbors base, decision tree classifier, SVM linear kernel, RB FSM, SVM radial kernel, GPC and MLP, Ridge, RF, QDA, ADA, GBC. Okay, so you can see that lot of models are available here. So these are the models that are available in the PyCaret, and you can select any of this model for doing your task. So let's say will be using the very basic linear discriminant analysis model, okay, for my classification. So first what I have to do is that I have to create a model. So to create a model, again, what I have to do, I have to call the function. Okay, I have to import that function. Okay, so from PyCaret dot classification import create underscore. So I can create a model, I can create a API, I can create a app, I can create a Docker. So here I'm creating my model. So I'm directing model, and I will going to run it. Okay, so here I will be using the LDA model and the decision tree classifier model. So I will be creating this. So I have to call this LDA model with the help of a create function. So LDA, I'm giving the variable name as a LDA right now. Create underscore model, and what model I want? I want the LDA model. Okay, so let me run this. So now you can see that it has created a model with the LDA, and now you can see that it has created the different fold. Okay, so we have gone with the 10 fold problem. So you can see that fold number 0, we are getting the accuracy. Another parameter, we have got a AUC, recall, precision, F1, kappa, MCC. So these are the performance measurement by which your model will going to give you the how it has been performing. Okay, so we have got a fold 0, fold 1, fold 2, fold 3, fold 4, fold 5, fold 6, fold 7, fold 8, fold 9. So total how many fold? We have got 10 folds. So if you remember the k fold which we have when we have created the setup, we have got a by default 10 fold, and then we are taking the mean of it. Okay, and then we have got a standard deviation of it. Okay, so let's say I was getting a very good accuracy at the fold 0. So I was getting the 100% accuracy. Okay. But as fold number 1, I was getting very less accuracy. I was getting the 75% as the accuracy. Okay. So it happens that some of the samples can get the 100% accuracy, and some of the samples may not have the 100% accuracy. Okay. And when we are working on a small data set, what we have to do, we have to work on a we have to use the folding schemes, okay, so that every data can be checked how it has been performing with respect to the particular samples. Okay, so you can see that the mean average which we are getting is the 96% accuracy we are getting. Let me go with the another model. So we will going to see the decision tree model. So we will be writing a command dt equal to create underscore models, and here I will be writing dt, and again I will going to run it, and again it will go for the tenfold. Okay, and now you can see that when I was using the LDA, so at the fold number 2, if you see the fold number 2, I was getting the 100% accuracy with the LDA, but with the decision tree model, I was not getting the 100% accuracy as the fold number 2. It was 87.5% accuracy. And if you see overall result which I am getting is that I'm getting a good result of a 96% at the mean average of the accuracy. If we are talking about the accuracy, we are getting the 96%, and here we are getting a 94%. Okay, so how we can do now, we can compare the two models, that how the models are being performing. Okay, so we can compare this accuracy, AUC, recall, precision, F1 scores, and we will going to see that how these functions are working with respect to each other. So now what we have to do, we have to compare these two model. Okay, so if we have already seen the accuracy of the LDA was good, but the accuracy of decision tree classifier was not good. Okay, so we want to do the comparison with respect to the other parameters also. Okay, what the performance parameter we are getting. Okay, so here we can write the comparison. So I will be writing from PyCaret dot classification import compare underscore models. Okay, let me run this, and now what we will going to do, we will going to compare. Okay, what is the best model we are getting. Okay, so let's say I'm saying, okay, best model, I'm writing the name best model equal to compare underscore model equal to what are the models we want. Okay, we want that these two models should be included. Okay, we can compare different model, but we are just right now we are doing with the these two models, so we will be including these two models. So we will be writing models compare model include what we want to include the dt, and then we want to include the LDA. Now we will going to run this. So again, see that same result we are getting. So you can see it is also highlighting. Okay, so we have got a good accuracy with the LDA. Okay, but we were getting the AUC good with the decision tree. Okay, then recall, precision, F1, kappa, and MCC we are getting the again very good with the LDA. This performance was not good with the decision tree classifier. Okay, so like this, what you can do is you can compare the different models, and you can see that how much time they have taken. What are the total time they have used to run this algorithm? So you can say time taken is the 0.0360 for the LDA and 0.039 for the decision tree. So use this parameter that okay, what are the computation time they have taken to run this algorithm. Okay, so you can compare this different algorithm based on their computation time. So you can see that this model which we have done here, so we have compared the best model. So we have got that okay, now right now we are just focusing on the accuracy only. So LDA is giving the best accuracy to us.